Hi there, algebra fans. Mrs. Lindsay back to talk to you a little bit about factoring trinomials completely. So you think you factored trinomials, but have you factored them completely? Well, let's find out. Let's practice factoring the GCF for a moment. So our first example, 6x to the 8th plus 30x to the 7th plus 36x to the 6th, has quite a few GCFs. First of all, 6, 30, and 36 has a GCF of 6. X to the 8th, x to the 7th, and x to the 6th, if we take the smallest exponent, our GCF here is x to the 6th. So we're going to divide each of these terms by 6x to the 6th. First, we write down our GCF, 6x to the 6th. Then, in our resulting parentheses, we have left a trinomial that results from dividing 6x to the 6th. So 6x to the 8th divided by 6x to the 6th is x squared. 30x to the 7th divided by 6x to the 6th is 5x. And 36x to the 6th divided by 6x to the 6th is simply 6. The x to the 6ths cancel out. So we're left at the end with a constant. Let's look at number 2. X to the 3rd plus 6x squared plus 5x. Well, here our lead coefficient is 1, and 1, 6, and 5 have no GCF, just 1. But we do have a GCF with the variables of x to the 1st, our smallest exponent. So we're going to divide each of these terms by x. So if you notice, we have no coefficient, but our variables reduce by 1 in each case. So first we write our GCF of x, and then our resulting parentheses, we're left with x squared, x, or 6x rather, and 5. 5 is a constant. Notice how the x is canceled out. In number 3, our lead coefficient is a negative. This is really not ideal. What we really need to do when our lead coefficient is negative is divide by a negative GCF. Now 4, 4, and 24, our GCF is 4. So we know we're going to divide each of these terms by 4. But because that lead coefficient is negative, we're going to divide each of those terms by negative 4. Therefore, we're going to change each of these signs, and the lead coefficient will now change from negative to positive. I don't really care that the other two terms change to negative, as long as the lead coefficient is positive. So my GCF is going to be negative 4, and my resulting trinomial, my resulting parentheses, is going to be x squared minus x minus 6. Each sign will change, and now I'm left with a positive lead coefficient. Let's look at number 4 for a minute. Number 4, we have as coefficients 6, 10, and negative 4. Well, our GCF of 6, 10, and negative 4 is 2. Our GCF of x to the 3rd, x squared, and x is the smallest exponent of x. So I'm going to have to divide each of these terms by 2x. 2x is my GCF. That comes out front. My resulting trinomial, when I divide by 2x, is going to be 6 divided by 2, or 3, and it's going to come down 1x, so 3x squared plus 5x minus 2. A couple of days ago, we would have been finished after factoring the GCF. But now, we need to look at the resulting trinomial and notice that in the resulting trinomial, we can actually factor again. There are two factors that multiply to 6 and add to 5. So we can actually factor this trinomial again. First thing, bring down the GCF. That never goes away. You worked hard to factor that, it stays. But x squared plus 5x plus 6 factor again into two binomials, which add to 5, multiply to 6, x plus 2, x plus 3. So here's your fully factored trinomial. 6x to the 6th, there's your GCF factor, and your two binomial factors, x plus 2, x plus 3. Let's look at number 2. We factored out an x as a GCF, but the resulting trinomial actually factors again. There are two factors that multiply to 5 and add to 6. They are 5 and 1. So bring down your GCF of x and factor x squared plus 6 plus 5 into x plus 5, x plus 1. Here is your fully factored trinomial, x, which is your GCF, and x plus 5, x plus 1, which are your two binomial factors. Now, here's why it's so important in number 3 to factor out the negative. We need a positive lead coefficient in order to factor into two binomials. X squared minus x minus 6, we can easily find two factors that multiply to negative 6 and add to negative 1. They are minus 3 and positive 2. So our fully factored trinomial is negative 4, my GCF, factoring out a negative, making the lead coefficient positive, making it possible to factor into two binomials, x minus 3, x plus 2. Number 4 is a little bit more difficult because my lead coefficient is greater than 1. So I bring down my 2x, but factoring the two binomials, I have to figure out a method to split this 3x squared term. I could try guess and check, and it might work, splitting up 3x squared into 3x and x, and negative 2 does split into two factors, negative 1 and 2, but it's going to be difficult to figure out how to arrange these two. I could try guess and check, and it does work because 3x times 2 is 6x minus 1x does give you the middle term of 5x. So that is the fully factored trinomial. Your GCF, 2x, your two binomials, 3x minus 1 and x plus 2. If you weren't sure how to factor these by guess and check, you could try the grouping method we learned yesterday. Multiply 3 times negative 2, and now you're looking for two factors that multiply to negative 6 and add to 5, replacing the 5x with 6x and negative 1x, grouping the first two, grouping the second two, and pulling out the GCFs. Now you have common binomial of x plus 2, and your two resulting GCFs form the second binomial, 3x minus 1. So here's our resulting three factors, our GCF and our two binomials. What happens if we forget about factoring out the GCF? What happens if we try to go right to the double binomial first? Well, first of all, it would be difficult. We could try to multiply the a times the c, the lead coefficient times the constant. 4 times negative 24 is negative 96. Two numbers that multiply to negative 96 and add to negative 4. Your calculator will help you. So if you go to the table, you will find that 8 and negative 12 add to negative 4. So we can replace the negative 4x with 8x and negative 12x. So here I'm going to try that. I'll group the first two terms, group the second two terms, and look for GCFs. 4x squared plus 8x has a GCF of 4x, leaving a resulting binomial of x plus 2. Negative 12x minus 24 has a GCF of negative 12, leaving a resulting binomial also of x plus 2. I can look at my common binomials and rip them out. So x plus 2 comes out front, and the resulting GCFs form the second binomial of 4x minus 12. But you need to inspect your two binomials. X plus 2 is fine, but 4x minus 12 already has a GCF. So 4x minus 12 has a GCF. You've got to stop right there. Look at 4x minus 12. There can't be a GCF inside one of your resulting binomials. It's not factored completely. So instead of going back to the beginning and factoring out the GCF, which you probably should have done in the beginning, let's just start from there and factor my resulting binomial that has the GCF, my 4x minus 12. If I factor the 4 out of my 4x minus 12 and then rewrite it out front, my final answer, 4 times x plus 2 times x minus 3, is what I would have gotten if I had ripped out my GCF first. But always remember that it's best to rip the GCF out first. Then you have an easier trinomial to factor, and you might not have to go through all this grouping. Let's try to factor something like this. Negative 2x squared minus 5x plus 3. If I look at the coefficients, negative 2, negative 5, and 3, I don't see any apparent GCF. 2, 5, and 3 don't have a GCF except for 1. But if you remember, having a negative lead coefficient can lead to a lot of problems. So I really would rather have this negative 2 be a positive lead coefficient. It's very simple. When you factor out the GCF, if you have a negative lead coefficient, make sure you factor out a negative, even if it's negative 1. We can't factor a trinomial that has a negative lead coefficient. So if we factor out a negative 1, each of the signs of the terms change. So my negative 2x squared changes to positive 2x squared. My negative 5x changes to positive 5x. And my positive 3 changes to negative 3. As long as I have a positive lead coefficient, that's all I'm really concerned about. So now I'm going to factor this trinomial. If I don't readily know how to factor this trinomial because it has a lead coefficient of 2, I make sure I multiply my lead coefficient with my constant, my a times my c term. So 2 times negative 3 multiplies to negative 6. What are two factors of negative 6 that add to my middle term of positive 5? Well, 6 and negative 1. So I can replace my positive 5x with 6x and negative 1x. Or I can use the box method. I'm going to try the box method. So my first term, 2x squared, and my last term, negative 3, get arranged in the diagonals of the box, 2x squared and negative 3. My 5x term gets rewritten as 6x and negative 1x in the other two boxes. Now I GCF. If I can find the GCF of 2x squared and 6x, well, 2 and 6 is 2, and x squared and x is x, so that results in 2x. My GCF of negative 1x and negative 3 has to be a negative 1, because remember, I can't have this negative lead coefficient. So because there's no other GCF in 1 and 3, I factor out negative 1. Now let's look at the side of the box. So 2x squared and negative 1x, well, 2 and negative 1 don't have a GCF, but x squared and x, we get x. And 6x and negative 3 have a GCF of 3. Remember, because it's a positive lead coefficient, we can rip out a positive. So don't forget to bring down your GCF of negative 1. And your two binomials are 2x minus 1 and x plus 3. If you want to try the grouping method, you can replace positive 5x, like we did yesterday, with 6x and negative 1x, Group 2x squared plus 6x and group negative 1x minus 3 and pull out the GCFs. Notice how I'm bringing the GCF down at every step. So that negative 1 comes down and just sort of hangs out there to the side. So 2x squared plus 6x, GCF is 2x, and the resulting binomial is x plus 3. I can't rip out a GCF of negative 1x minus 3x, except I need to rip out a negative 1 to make sure that that lead coefficient is positive. So my resulting binomials are a common binomial of x plus 3. That goes right there. And my resulting GCFs are 2x minus 1. That goes in a separate binomial. Final answer, negative 1, which was my original GCF, times my two binomials I got from either my box method or my grouping method, whichever you prefer, 2x minus 1 times x plus 3. That's all for now. We'll practice this more tomorrow. Remember, step 1, look for a GCF, even if it's negative, to get the lead coefficient to be positive. Look for your GCF, and then try again to factor your resulting trinomial into two binomials to get your final answer. You may have 3 final factors, a GCF and 2 binomials. See you tomorrow. Have a good night.